Well, good evening. Wonky Astronomer here, coming to you from the Gazo, aka Hazelbrook Observatory. The great Arecibo radio telescope in Puerto Rico. You may remember it for being featured in a Bond movie, sending cryptic messages to aliens, or more recently for collapsing in a pile of rubble. But in the 57 years before it collapsed in a pile of rubble, it also did some science, including radar imaging of asteroids. So it's very appropriate that an asteroid would be named after the great telescope. 4337 Arecibo is a main belt asteroid which orbits the Sun between Mars and Jupiter in about 6 years. And on the morning of May 20th, 2021, it was predicted to occult a star in the constellation of Sagittarius. The shadow was due to pass over my observatory here in Hazelbrook and also over my colleague Dave's observatory, about 18 kilometres east of here. So we both got up in the middle of the night to record the event, which was due at about 4 a.m. We observe many similar events, sometimes several in a week, so this one was nothing special, except that the Occult Watcher app was showing a 97% probability of success, which is unusually high. This is how the session unfolded. Well, good evening. Wonky Astronomer here. Well, it's the asteroid 4337 Arecibo, yeah. And I'm on target. And so is Dave. And I've only got 20-something seconds left. Target star is here. And it's a very high probability. So let's watch. Oh, yes. Oh, and back. Nice. It's my first positive for quite some time. With such a high probability, we weren't surprised that we both got positives. That is, the star disappeared for a couple of seconds as the asteroid moved in front of it. But while I was saying nice and wallowing in self-congratulation, I totally missed the really important bit. Nice. 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 Did you see it? The star disappeared a second time. Nice. So I went back to sleep, oblivious to what I had just recorded. But later that morning, I ran my recording through Tangra software to generate the light curve. And this is what I saw. A double dip. I immediately thought the second dip was caused by a moon, but I knew that a single observation could have another explanation. Perhaps a completely separate asteroid, or a bird, or a paper bag carried by the wind, or something unknown like, well, I'm not saying it's aliens, I'm not saying that, but some object that's flying and unidentified. And even if it was real, without confirmation by another observer, it wouldn't be recognised as a discovery. But if Dave got a similar result from his location, 18 kilometres away, then we might really have something. So I emailed my light curve to Dave, but he was at work and hadn't yet checked his light curve. But he replied like this. That evening, when Dave got home, he called me and said that he had also got a double dip. Soon after that, he sent me his light curve, which, like mine, showed the second dip very clearly. So we were pretty sure that we had a moon on our hands. This is what we believed had happened. The asteroid covered the star briefly, causing the first dip in the light curve, followed by the smaller moon, causing a shorter dip. In this scenario, assuming both objects are roughly spherical, our chords can be plotted to show that the main body is about 24 kilometres across. But the size of the moon isn't clear because our chords are too close to the edge. But what if the star was actually a double star? The asteroid might occult each of them separately, causing two dips in the light. Could that explain our observations? Well, we spent a lot of time analysing our data to see whether a double star could explain our light curves. And we thought we'd proved that a double star could not be the explanation. But very soon, that all became moot. You see, we'd already put out the word on the Occultation forums that Arecibo might have a moon. And we'd asked for other people to observe any future occultations by that asteroid. And on June 9th, only 3 weeks after our observations, there was another good occultation visible from California. 2 observers, Richard and Kirk, decided to try to observe it. And it certainly wasn't an easy event to observe. They had to drive more than 100 miles to get to the shadow path for the event, which was due at about 4 a.m. local time. So I woke up on the morning of June 10th and found an email saying that Richard and Kirk had both recorded double dips in their light curves.
Yes! All right! We got the main body and we got the moon. Excellent.
So that made the case for a moon very solid indeed. From Richard and Kirk's observations, we think the asteroid is about 24 kilometres across, and the moon is about half that size. And as far as we can tell, this is the first time an asteroid moon has been discovered and confirmed entirely by the occultation method. We then submitted a brief announcement of the discovery to the Central Bureau for Astronomical Telegrams, and that was published on June 20th. The publication of that telegram, or CBET, ensures that we get credit for the discovery. But it's very brief, and we need to follow up by submitting a more detailed paper to a scientific journal. There's more information about this on the Hazelbrook Observatory website, link in the description below. So there you have it. That's how you discover a moon.